There are many factors to be considered in the choice and use of wire rope for rigging and hoisting. One of the most important is safety. Although you must select equipment that will get the job done economically, you must also eliminate any hazard to people and property. Use only wire ropes of the size, grade, and construction specified by the manufacturers of hoisting equipment or wire rope. They base their recommendations on actual working conditions. In this session, you will learn how to identify, select, and safely use the wire ropes required for rigging and hoisting in construction. The topics we will cover are wire rope construction and characteristics, safe working load, inspection, replacement criteria, and use, handling, and maintenance. Wire rope is usually made up of a number of wires laid into a strand and a number of strands laid around a core. The core may be an independent wire rope or a fiber rope. The term rope lay signifies the direction of rotation of the wires and the strands in the rope. Rotation is either to the right, clockwise, or to the left, counterclockwise. The lay of the rope affects its flexibility and resistance to wear. The term lay length means the distance in which a strand makes one complete revolution around the rope axis. Lay length is 6 to 7 rope diameters for most wire ropes. In regular lay ropes, the wires in the strands are laid in one direction, while the strands in the rope are laid in the opposite direction. These ropes have good resistance to kinking and twisting. They can also withstand considerable crushing and distortion because only short lengths of wire are exposed on the outer surface. In Langley ropes, the wires in the strands and the strands in the rope are laid in the same direction. The outer wires have a greater exposed area than regular lay rope and are therefore more resistant to abrasion. They are also more flexible and have greater resistance to fatigue. However, Langley ropes are more susceptible to distortion, crushing, kinking, and untwisting than are regular lay ropes. For this reason, both ends should be fixed so that rotation is prevented. They should not be used on single-part hoist lines or with swivel end connectors. Most wire ropes used in construction are right regular lay. This means that the strands twist to the right, while the wires twist to the left. The core forms the heart of the rope and is the component around which the main rope strands are laid. The core supports the strands and is intended to keep them from jamming against each other under normal loads and flexings. Wire rope is generally independent wire rope core, IWRC, or fiber core, FC. The fiber may be synthetic or natural. Rope with independent wire rope core is more crush resistant than fiber core rope. It is also, to a certain degree, heat resistant and is slightly stronger than fiber core rope of the same diameter and construction. Wire rope core would be used, for example, where there are multiple layers of wire rope on a take-up drum or winch. Fiber core rope is more flexible than wire core rope of the same diameter and is also less costly. The type and size of wire used, the number of wires in the strands, the type of core along with its diameter determine the strength of a wire rope. A typical wire rope designation would be half-inch diameter, 6 by 19 seal preformed, improved plow steel, IWRC, right regular lay. The half-inch diameter is a nominal diameter. Most new wire ropes are oversized by up to 5%. Measure wire ropes from crown to crown on opposite strands to get the correct diameter. 6 by 19 seal. The first number is the number of strands in the rope, in this case 6. The second number is the number of wires in each strand, 19 in this case. The word seal indicates the pattern of wires in the strands. Other common configurations are Warrington, ordinary, and filler. Preformed refers to a process that forms the strands and wires into the spiral shape they will assume in the rope. Preforming prevents the wires and strands from straightening and brooming out after the rope has been cut. Improved plow steel, or IPS, is now the most common grade of steel used in wire ropes, although extra improved plow steel is becoming more popular. IWRC stands for Independent Wire Rope Core. FC or fiber cores are also used. Right regular lay indicates that the wires in the strands twist to the left, while the strands themselves twist to the right. The construction of wire rope determines many of its properties. The least flexible is 6x7. It is mainly used for guy wires and other stationary applications. It can be either wire rope core or fiber core. The 6x19 construction is more flexible and one of the most commonly used wire ropes for slings. This classification covers ropes with 6 strands having 8 to 26 wires per strand. These two can be IWRC or FC. The 6x37 classification includes ropes that have excellent flexibility, reasonable resistance to crushing, and are well adapted to high speed and multiple reeving applications. This classification covers ropes with 6 strands having 27 to 49 wires per strand. In rotation-resistant ropes, the rotation-resistant characteristic is achieved by building into the rope 2 layers of strands, one having right lay and the other left lay. When loaded, the tendency of the outer layer of strands to rotate in one direction is counteracted by the tendency of the inner layer of strands to rotate in the opposite direction. Some rotation-resistant constructions incorporate 3 layers. Rotation-resistant ropes are popular for use as hoisting lines on cranes. Before using wire rope for any hoisting application, you must know the strength of the rope and the magnitude of the load to be applied to it. In connection with these factors, 3 abbreviations are commonly used in rigging. SWL means safe working load. This is the load which can be applied repeatedly without overloading the rope, provided the rope is in good condition. BS stands for breaking strength. That's the load at which the rope breaks when new. FS stands for factor of safety. This is the ratio of breaking strength to safe working load. 3 standard formulas express the relationship between these 3 quantities. Safe working load equals breaking strength divided by factor of safety. Breaking strength equals safe working load times factor of safety. Factor of safety equals breaking strength divided by safe working load. The factor of safety is 3 to 1 for pendants, 3.5 to 1 for hoist lines on mobile cranes, 5 to 1 for all slings, and 5 to 1 for hoist lines on tower cranes, and 10 to 1 for wire ropes used on personnel hoists. If you don't know the safe working load of a wire rope, use the following rule of thumb to compute the safe working load in tons. For a factor of safety of 5, the safe working load in tons equals rope diameter in inches times itself times 8. Or in other words, safe working load in tons equals D squared times 8. For a half-inch diameter wire rope, the safe working load is 1/2 times 1/2 times 8, which equals 4 over 8 times 4 over 8 times 8, or 16/8, which equals 2 tons. This rule of thumb formula applies to new ropes made of improved plow steel. The single most important operational check to be made on hoisting and rigging equipment is the rope and rigging inspection. Safety and economy dictate the need for periodic inspections of all load-supporting wire rope and fittings. Factors such as insufficient lubrication, abrasion, wear, fatigue, corrosion, improper reeving, and kinking are often more significant in determining the usable life of wire rope than strength factors based on new rope conditions. All wire rope in continuous service should be monitored daily during normal operation and inspected on a weekly basis. A complete and thorough inspection of all ropes in use must be made at least once a month. All rope idle for a month or more should be thoroughly inspected before it is put back into service. Rotation-resistant wire ropes require very careful inspection. They tend to wear from the inside out because the two layers of strands rub against each other during normal use. Before any damage or wear can be seen on the outside of the rope, it can be severely damaged inside. One of the easiest ways to detect inside breaks is to hold a length of the rope up to your ear and bend it. Run the bend back and forth through the length. If you hear a crackling or a popping noise, there are likely broken wires inside the rope. Pay particular attention to areas close to end fittings. Where multi-layered drums are used, examine not only the rope in constant use, but also the rope that is spooled and inoperative on the drum. Examine all ropes, including standing ropes, for possible defects caused by corrosion, abrasive dust, and erection and dismantling procedures. Permanent damage and deformation, such as kinks, crushed, flattened, and distorted strands, and uneven wear are the conditions which make a rope extremely susceptible to failure. The weakest part of a rope determines the overall strength of the rope. The weak point may be where the rope is badly worn, where it has a number of broken wires, where the stresses are unequal in the strands, where bending the rope over a sheave creates wear and tear, or where the rope is attached to equipment or loads. Only inspection can detect potential hazards and reduce accidents. Construction regulations under the Occupational Health and Safety Act state that steel wire rope must not be used where 6 randomly distributed wires are broken in one rope lay, or 3 or more wires are broken in one strand in any rope lay, where wear exceeds 1/3 of the original diameter of outside wires, where there is kinking, bird caging, corrosion, or any other damage resulting in distortion of the rope structure, or where there is evidence of any other possible cause of rope failure, including contact with electricity. The regulations go on to state the allowable reduction in diameter for various size ropes. Steel wire rope that is static or used for pendants should not be used if there are 3 or more broken wires in one lay in sections between end connectors, or if there is more than one broken wire at an end connector. Wire ropes require careful use, handling, and maintenance for long and safe performance. Ensure that the correct size, grade, and construction of rope is used. Inspect the rope regularly. Never overload. Avoid shock loading. Shock loads will increase the load in the rope dramatically. Broken wire ends should be removed as soon as possible by bending the broken ends backwards and forwards with a pair of pliers. This way, the wire is more likely to break inside the rope where the end can do no harm. Take special precautions and/or use a larger size rope and appropriate hardware whenever the exact load distribution is not known, there is a possibility of shock loading, or there is a hazard to personnel. Use padding or softeners to protect rope from sharp corners or edges. Never drag the rope from under loads or over obstacles. Always use blocking under the load. Avoid dropping the rope from heights. Never roll loads with ropes. Store all unused rope in a clean, dry place, preferably off the ground. Never use rope which has been cut, badly kinked, crushed, or otherwise misused. Lubrication is the prime factor in extending the working life of wire rope. Lubrication not only reduces friction between individual wires in a rope, it can also prevent internal rusting. Most wire rope is lubricated before it leaves the manufacturer. But even well-lubricated wire rope should not be unduly exposed to the elements. Wire rope exposed for long periods of time should be checked frequently for damage, corrosion, and possible breakdown of lubricant. Wire rope should be cleaned and lubricated regularly, according to the rope manufacturer's recommendations. Remember that in regular lay ropes, the strands and the wires are laid in opposite directions. Lang lay ropes have the wires and the strands laid in the same direction. Rotation-resistant ropes have 2 or 3 layers of strands laid in opposite directions to each other. Strands containing a large number of small wires are more flexible and resistant to bending fatigue than strands containing a few large wires. On the other hand, large outer wires are better able to withstand abrasion. The factor of safety used in calculating safe working load is 3 for pendants, 3.5 for hoist lines on mobile cranes, 5 for hoist lines on tower cranes and all slings, and 10 for personnel hoists. For a safety factor of 5, the safe working load of a wire rope can be calculated by multiplying the square of the diameter in inches by 8. Ropes should be inspected regularly, especially the sections subjected to bending, abrasion, and vibration. The rope should be taken out of service if there is any doubt about its reliability. Proper use and maintenance will ensure that wire ropes retain strength throughout their working life. You should now know how to identify various wire ropes by construction, rated loads, and application. You should know how to calculate safe working loads and how to properly handle, maintain, and apply wire ropes to typical construction purposes. Further information is available from your Construction Safety Association of Ontario.